Hey, this is Mr. Barr, and today we're going to be graphing exponential functions. So let's start with our learning goal. I can use exponential functions to model real-life situations. Why exponential functions show up in science and economics. I want to understand how they are used. You are going to need a scientific calculator for this, something that can do exponents easily and fractional exponents. Yes, there are online ones, but your life is going to be so much more effective or efficient and easy if you'll get a decent scientific calculator. Here's the one that I'll be using. I've got a Casio two-line calculator. Okay, you're going to need a calculator. We're going to graph this function. I want you to remember earlier in this class that I told you early on, you can graph anything. I want to emphasize this. Here, where's my face? Am I on this thing? You can graph anything. Throw out a net. Like go from -5 to 5. Plug that into the function and get the y values. You plug in a bunch of x's, you get out a bunch of y's, and you graph it. You can graph anything, and that's what we're going to do here. We're going to plug in x's, we're going to get out y's, and we're going to plot those points. You can graph anything. Boom. Okay. So let's start with our name and the title. Graphing exponential functions. And it's going to start with the table. We're going to make a table of values, and then we'll plot the points. So in this case, we're going to be graphing y equals 10 times 1/2 raised to the 0.5x. This is what we're about to graph. This is an exponential function. And we're going to plug in 0. You know what? We're going to plug in -1. I'm going to change it. We're going to plug in -1, 0, 1, 2, 3, 4, 5. Now, I'm going to put an in-between step in here so that I don't have to keep plugging 0.5 times x into my calculator. So I'm going to do an in-between value here of 0.5x. So let's just take each of these numbers and cut them in half. This is really going to be my exponent that I'm about to use, right? It was x times 1/2, so x times 1/2. So this is the exponent that I'm about to use. And now with that exponent, ooh, just lost my lights. And now that we have that exponent, we're going to go find those y values. Okay, this is where the calculator earns its keep. Here we go. 1/2 raised to the -0.5 power equals that number times 10. 14.14. 1/2 raised to the 0 power which I already know is going to be 1, times 10 is 10. One half raised to the 1/2 power times 10, 7.1. One half raised to the 1 power times 10 is 5. And I'm just going to keep going like this. I'm just going to keep plugging in numbers. 0.5 raised to the 1.5 power times 10. 0.5 raised to the 2nd power times 10. 0.5 raised to the 2.5 power times 10. Now I have a table of values. Now I'm going to plot this table of values. So here's my graph paper. And my first point was -1, 14. -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. My second point was 0, 10. This is 14. Just went down 4, 0, 10. My next point was 1, 7.1. 1, 2, 3, 4, 5, 6, 7.1. Next point, 2, 5. Next point, 3, 3.5. Next point, 4, 2.5. Next point, 5, 1.8. And you know what? Just so we can figure out what's going on, let's plug in 1, 2, let's plug in a 10. Let's plug in a 10 and see what's happening out here. Let's plug in a 10. So we're plugging in a 10. That means the exponent is going to be half of 10, which is 5. So we're going to take our calculator. We're going to do 0.5 raised to the 5th power times 10, 0.3. So over here at 10, it's at 0.3. 1, 2, 3. This is what? 2, 4, 6, 8, 10. So this curve is coming down. There's our graph. Oh, but Mr. Barr, that takes so much time. Yes, it takes time. Oh, but Mr. Barr, there are online things that'll do this for us. Yes. There are also these crazy machines that'll drive you around. They're called cars. They don't help you train for a marathon. Driving in a car, yes, it gets you somewhere, but it doesn't help you physically get any stronger. Yes, there is graphing software out there that'll graph all these, but they do not help you mentally get stronger. Yes, they're useful. All right, so that is how you graph an exponential function. How do we do? Does it look like, does my graph look like that graph? Sure does. Looks really good. Okay, this would be a similar type of problem. We're going to do a similar type of problem. Yeah, they're all going to work the same way. You're going to make a table of values, fill it in, and then graph it. So let's do this one. I don't expect you to do this one in your notes. I'm just going to do it quickly on the computer. Okay. 0. Okay, so if I plug in 0, anything with 0 power is 1 times 10 is 10. So this is going to be a 10. Now I'm doing 0.1 raised to the 0.5 power times 10 gives me 3.1. Half of 2 is 1, so I'm doing 0.1 raised to the first power times 10, which is going to be 1. Half of 3 is 1.5, so I'm doing 0.1 raised to the 1.5 power times 10 is 0.31. Half of 4 is 1. 0.1 times 10 is 1. Something went wrong. Half of 4 is 2. Half of 4 is 2. So 0.1 to the second power times 10 is 0.1. It's getting tiny. Okay, 0 I'm at 10. 1 I'm at 3.1. 2 I'm at 1. And at 4 I'm practically on the line. How do we do? Ooh, that looks pretty good, right? That looks good. All right, that's how you do it. You will need graph paper to do the work for today. Take your time, draw the tables, fill them in, graph it. You've got this. Thank you.